Welcome you all. I am Dr. Jahan, Associate Professor, Electronics and Communication Department from Rohini College of Engineering and Technology, Kanyakumari. So this video I have discussed about ADA wireless sensor networks. Wireless sensor network application with examples. The claim of wireless sensor network proponents is that this technological vision will facilitate many existing application areas and bring into existence entirely new ones. This claim depends on many factors, but a couple of the envisioned application scenarios shall be highlighted. Apart from the need to build a cheap, simple to program and networks, potentially long-lasting sensor nodes, a crucial and primary ingredient for developing actual applications is the actual sensing and actuating faculties with which a sensor node can be endowed. For many physical parameters, appropriate sensor technology exists that can be integrated in a node for a wireless sensor network. Some of the few popular ones are temperatures, humidity, visual and infrared light from simple luminance to cameras. Acoustic vibrations, example for detecting seismic disturbances, pressure, chemical sensors for gases of different types or to judge soil composition. Mechanical strength, magnetic sensors to detect passing vehicles, potentially even radar, but even more sophisticated sensing capabilities are conceivable. For example, toys in a kindergarten might have tactile or motion sensor or to be able to determine their own speed or location. Actuators controlled by a node of a wireless sensor networks are perhaps not quite as multifaceted. Typically, they control a mechanical device like a servo drive, or they might switch some electrical appliance by means of an electric relay like a lamp, a bullhorn, or a similar device. On the basis of nodes that have such sensing and actuation faculties in combination with computations and communication abilities, many different kinds of applications can be constructed with very different types of nodes, even of different kinds within one application. A brief list of scenarios should make the vast design space and the very different requirements of various applications. Disaster relief applications. One of the most often mentioned application types of for wireless sensor networks are disaster relief operations. A typical scenario is welfare detection. Sensor nodes are equipped with thermometers and can determine their own locations related to each other or in absolute coordinates. Yes. Absolute coordinates. These sensors are deployed over a wildfire, for example, a forest from an airplane. They collectively produce a temperature map of the area or determine the the perimeters of areas with high temperatures that can be accessed from the outside, for example, by firefighters equipped with personal digital assistants. Similar scenarios are possible for the control of accidents in chemical factories. Environment control and biodiversity mapping. Wireless sensor networks can be used to control the environment, for example, with respect to chemical pollutants. A possible application is garbage dump sites. Another example is the surveillance of the marriage ground floor. An understanding of its erosion process is important for the construction of offshore wind farms. Closely related to environment control is the use of wireless sensor networks to gain an understanding of the number of plant and animal species that live in given habitat. Biodiversity mapping. The main advantages of wireless sensor networks here are the long-term unattended wire free operations of sensor close to the objects that have to be observed. Since the sensor can be made small enough to be unobstructive, they only negligibly disturb the observed animals and plants. Often, a large number of sensors is required with rather high requirements regarding intelligent buildings. Buildings waste vast amounts of energy by inefficient humidity, ventilation, air conditioning usage. A better real-time high resolution monitoring of temperatures, airflow, humidity, and other physical parameters in a building by means of wireless sensor networks can considerably increase the comfort level of inhabitants and reduce the energy consumption. Improved energy efficiency as well as improved convenience are some goals of intelligent buildings for which currently wired systems like BAC, NET, LANWorks or KNX are under development or already deployed. These standards also include the development of wireless components or have already incorporated them in the standard. In addition, such sensor nodes can be used to monitor mechanical stress levels of buildings in seismically active zones by measuring mechanical parameters like the bending load of girders. It is possible to quickly assess via a wireless sensor network whether it is still safe to enter a given building after an earthquake or whether the building is on the brink of collapse. A considerable advantage of rescue personnel. Similar system can be applied to bridges. Other types of sensors might be geared toward detecting people enclosed in a collapsed building and communicating such information to a facility management. In the management of facilities larger than a single building, wireless sensor networks have a wide range of possible applications. Simple examples include keyless entry applications where people wear badges that allow a wireless sensor network to check which person is allowed to enter which areas of the larger company site. This example can be extended to the direction of intruders, for example, vehicles that pass street outside of normal business hours. A wide area wireless sensor networks could track such a vehicle's position and alert security personnel. This application has many commonalities which are corresponding military applications. Along another line, a wireless sensor network could be used in a chemical plant to scan for leaking chemicals. These applications combine challenging requirements as a required number of sensors can be large by have to collaborate in the tracking example and they should be able to operate long